Hello everyone, welcome back. Today we're going to be working on lesson 1.15 and our learning target for today is I can compare and contrast situations using measures of center and measures of variability. So let's take a look at our lesson synthesis, and we're going to be analyzing multiple data sets. So in here we are going to be answering questions A, B, C, and D for 3 different representations of data sets. So let's take a look at question A for the first set of data that we see. So determine the best measure of center, mean or median, to use based on the shape of the distribution. So when we talk about shape, you want to make sure that you are either noticing if your distributions are symmetrical or skewed. And the reason why you want to take a look at this is because you want to make sure that you are either going to find the measure of center by either using the mean or the median. So let's take a look at the first one. So if we take a look at the first set of data, right, we first have to see if our data is symmetrical. So right away, once I find the middle of both data sets, I notice that both sides are symmetrical. My left side lines up with my right hand side. So if your data set is symmetrical, the best measure of center for symmetrical distributions is going to be the mean. Okay, so we're going to be using the mean for the measure of center. Now let's look at question B. So determine the best measure of variability, standard deviation, or the IQR, otherwise known as the interquartile range, to use based on the shape of the distribution. So since both of these data sets are symmetrical, and we are using the mean for the data of center, that means that we're also going to be using the standard deviation in order to measure the variability. So in this case, we're going to look for standard deviation. Why? Because it's symmetrical. So if it's symmetrical, obviously we're going to find the measure of center using the mean, and we're going to find the measure of variability using the standard deviation. Now, let's take a look at question C. So determine which set has the greatest measure of center. So now, when we talk about greatest measure of center, if most of your data points are shifted over to the right, that means that it has the most measure of center. So how do we determine that, right? You're going to find the middle or the approximate middle of each graph. So, or of each data set, I want to say. So for example, the middle of distribution 2A is around here between 19 and 21. And then the middle of distribution 2B is basically shifted over to the right. So in this case, which has the greatest measure of center, in this case is going to be display 2B. So always find the middle of both data sets, and you want to see basically which one's more shifted towards the right. Now let's take a look at that last question. So determine which data set has the greatest measure of variability. When we're talking about greatest measure of variability, you want to see how far apart your data spreads. So if we take a look at distribution 2A, we see that our data points are spread all throughout our dot plot, as compared to our data in 2B, they're kind of all squished to the right hand side. So in this case, distribution 2A would have the most greatest measure of variability. And just to recap what we just talked about, right? So if your displays are symmetric And you're going to be basically trying to find the center of measure using the mean. If the measure of center is mean, obviously, in order to find the measure of variability, you're going to use standard deviation. If your data displays are basically the middle, if it's more shifted towards the right, like we said here, right, then that has the greatest measure of center. And if we see our dots spread throughout, then we see more spread in the data points, right? Then it has the greatest measure of variability. So let's take a look at distribution 3A and 3B. So these distributions are kind of skewed, right? So here we kind of see that it is not symmetrical, right? So if they are not symmetrical, then instead we're going to be using the median. So we're going to be finding the center of measure using the median. So find approximately the middle point for about each one. We see that they're not the same on both sides. So data displays in this case are considered skewed. So what about the measure of variability? In this case, we're not going to be using the standard deviation. Instead, we're going to be using the IQR, right? And the reason why is because the measure of center in this case, if our data displays are not symmetrical, they're a little bit skewed, then our measure of center is essentially the median. So determine which set has the greatest measure of center, right? So like I said, you want to find the middle. And if most of your dots in your dot plots are more shifted towards the right-hand side, then that has the greatest measure of center. So if we take a look at both, we see that the greatest measure of center in this case is going to be display 3A, because most of our dots are essentially towards the right hand side. Determine which set has the greatest measure of variability, and this is very simple, right? We want to make sure that we're looking at the spread of the dots in total. So if we take a look at distribution 3A, most of our dots are spread throughout, so meaning that distribution 3A has the greatest measure of variability. Now let's take a look at distributions 5A and 5B. So in this case, we actually have box plots. So if we have box plots, right, in this case, our distributions are not really symmetrical. We can't really tell. But if we have box plots, we do have one piece of information that is completely necessary for us to know, and that is going to be the median. So in order for us to find the measure of center, we're going to be using the median instead for box plots. And of course, the displays are essentially skewed. So when it comes to the greatest measure of variability, we can't really tell the standard deviation from here. So in this case, we can find the IQR using our formula Q3 minus Q1 to find the measure of center. And in this case, our measure of center, since we're using box plots, is going to be the median. So in this case, in order to find the greatest variability, we're going to use the IQR. So now determine which set has the greatest measure of center. So like I said, right, this is actually very simple to see in box plots. Wherever your box plot is more shifted towards the right, that is the one that you're going to pick that has the greatest measure of center. So in this case, it would be distribution 5A. And why? Because the middle is basically more further towards the right. You're basically just looking at the median in our box plots in this case. And then last but not least, right, determine which set has the greatest measure of variability. So we want to take a look and see which box is wider. So when we take a look at box plots and compare both box plots in terms of size, we see that distribution 5A is actually a lot bigger than distribution 5B. And that's that.